This is section 2.4, and it's about one-sided limits. And so we'll note here in the limit notation, as limit as x approaches c, and there's a little plus here, there's a minus here. The plus says you're taking the limit from the right. The minus says you're taking it from the left. So let's look at what that looks like graphically. So we have this where this graph is this blue part, y equals x divided by the absolute value of x. The limit as you approach 0 from the right. So as you come in this way, where's the limit? That's at, as you approach from the right, it's 1. As you approach from the left, you're at -1. And so the limit in general as you approach 0 does not exist because they are different limits and they have to be the same. You can have a right-sided limit, you can have a left-hand limit, but if they're not the same, then the limit doesn't exist. Then here is a rule that becomes pretty important. Limits involving sine theta over theta. The limit as theta approaches 0 of sine theta over theta is equal to 1. So we want to learn that one. In this example, show that the limit as x approaches 0 of sine 2x over 5x is equal to 2/5. So we have to prove that. Well, we need a 2x in the denominator in order to have this, because it's sine of this argument over that argument equals 1. So we need that 2x to be here. That's the goal. So if we multiply both the numerator and the denominator by 2/5, let's see what that looks like. So we have the sine, the limit, and then we have it over here. It's the same thing as if we multiplied 2/5 times that one, 2/5 times the bottom. We can do that because that's equal to 1. All right? And so down here on the bottom, you've got 2/5 times 5. That's just 1. So now we've got 2x on the bottom because we see the 5's cancel out and we've got 2x. So now we've got the limit as x approaches 0 of 2/5 sine 2x over 2x. All right, now that allows us to begin to look at our rule. This constant that's on the outside, we can pull through, and 2/5 comes on the outside. Limit as x approaches 0 of sine x over 2x. And that sine x over 2x, that limit as we approach 0 is 1. And so this whole thing right here, this whole piece becomes 1, and 1 times 2/5 equals 2/5. So sometimes we just have to manipulate it to get it to have the same argument here as the denominator. Let's look at another example. Find the limit as t approaches 0 of tan t secant 2t over 3t. Well, we need to have sines and cosines over there, so let's kind of rewrite. We can take out a 1 and a 3. If we pull that, we've got 1/3 outside the limit. Then we have the limit as t approaches 0 of sine t over t. That's the tan. Tan is sine over cosine. So we've got sine t and cosine t on the bottom. That takes care of the tan. So the sine over cosine takes care of the tan. Remember, this 3 is gone. It's out here. And so you have 1 over t. So now this piece is taken care of by this. The secant 2t is 1 over cosine 2t. That's the same thing. And so now sine t over t, as t goes to 0, remember sine t over t, you've got this rule, so that's going to be a 1. So that's a 1. 1 over cosine t, well, cosine of 0 is 1, so that's a 1. If you plug in 0 here, you've still got 1 over cosine 0. Cosine 0 is 1, so you've got 1/3 times all those 1s. It's just 1/3. This last one, like I think I rewrote this, so that's the same. I did just put these in here for a reminder. So that is the same thing, just perhaps worked out a little bit differently. So let's go look at our problem set. All right, number 1, use the following function and its graph to answer the questions. So we have this graph here, and I drew in the arrows here and said that at this point x is 5. So just keep that in mind. Find the limit of f of x as x approaches 3 from the right and 3 from the left. That's what that's saying. So as you come in to 3 from the right, what is the y value right here? That's 5. As you come into 3 from the left, the piece of the graph is here, and that y value is 3. Does the limit exist? Well, we know that it doesn't exist because those two limits are different. If they're not the same, the actual limit does not exist. C part, the limit as you approach 5 from the right and the left. Well, if you come in from the right, that means coming this way, you're at 7. If you're coming in from the left, you're also at 7. So the limit is 7 from the right, 7 from the left. And D, does the limit exist? Yes, because those two were the same. So that was number 1. So be sure that you can understand that part. Number 2, find the limit as x approaches negative 0.2 from the right of this. Well, we can actually just plug in that. And if we plug in negative 0.2 plus 11, you'd get 10.8, and negative 0.2 plus 2, and you get 1.8. And when you do that, you get the square root of 6. And so if you were doing that on your calculator just to get, because it says leave the answer in radical, so if you do 10.8 divided by 1.8, you do get 6. So this answer is the square root of 6. It did say to use radicals as needed. Let's go to number 3. Let me move this. The limit as x approaches c from the right. All right, well, here's your f of x, and c equals 8. So let's see what we need to do. So we are able to plug in 8 we are doing x approaches c from the right. We're able to plug in 8 for x in this. There shouldn't be any problem. So 4 times 8 over 8 plus 1. 6 times 8 plus 8 over 8 squared plus 8. We get 32 over 9 times 56 over 72. 8 will go into that 4 times. 8 goes into that 9 times. 4 times 56, 224. 9 times 9 is 81, and it says put your answer in a simplified fraction. So that one is not too difficult. Number 4, find the limit as y approaches 0 of sine 16y over 15y. And I wrote the rule that we need to keep in mind. Limit as theta approaches 0 of sine theta over theta equals 1. And I don't know where the 1 went. Let's see. Let's put that there. Okay. So we need 16y in the denominator here to make it look that this argument here is the same as this value here. So we need to multiply 15y by 16 over 15. Then the 15's cancel out and we get 16. So we know what we need to do to get to use this rule. You're going to multiply both the numerator and the denominator by 16 over 15. So we do that here and here. And so when you do it down here, you end up with 16y. And up here, you still have a 16/15. We pull that out to the outside of the limit. We can take this constant, pull it out. So now we have 16 over 15, the limit as y approaches 0 of sine 16y over 16y. That becomes 1, and 1 times 16 over 15 is 16/15. Okay? So you have to keep in mind what you're trying to get to. Number 5. Find the limit as x approaches 0 of x cosecant 11x cosine 15x on the bottom. Now what we have to realize, we can plug in 0 down here. And when we do, we've got the limit as x approaches 0, put in 0 there, so you have cosine of 0. That's just 1. That's just 1. So now our problem goes from having a denominator to limit of x as x approaches 0 of x cosecant 11x. We have to remember cosecant is 1 over sine. So we're going to have x on the top, and this cosecant 11x becomes 1 over sine 11x. So this is what we've got now. The limit as x approaches 0 of, we have this, x over sine 11x. I need this up here for the rule to stand. Remember, our rule is sine theta over theta, and you can also have theta over sine theta. That can be flipped. So up here, I need 11x up here. So I need to multiply 11 up top, 11 up down on the bottom. So the limit as x approaches 0 of 11x over 11 sine 11x. Okay? Now, this 1 over 11 can come out to the front of the limit sign. 1 over 11, limit as x approaches 0, 11x over sine 11x. That argument is the same as that number, so that becomes a 1. And so you've got 1/11 times this whole thing is 1, so you have 1 over 11. Okay? Always have to keep in mind what we try to get because we want to use the rule. On this one, find the limit as theta approaches negative pi of theta cosine theta. It's just a plug in. Negative pi cosine negative pi. Well, cosine of negative pi is negative 1. So negative pi times negative 1 is positive pi. That is the answer. You choose here, plug in here, and pi would go in the box. Number 7, the limit as x approaches 0 of tan 4x over sine 7x. Remember that tan is sine over cosine. Tan is sine over cosine. So, in order to do this, we'll rewrite this as sine 4x over cosine 4x. That takes care of the tan. And then we have 1 over sine 7x. All right? Now, ultimately, we need to have several things happen. For the sine 7x on the bottom, I got to have a 7x here. And I need a 4x on the top here. So, let's see what we can do. If I have 7x over 4x, 7x over 4x times 4/7, that cancels out, those 4's cancel out, the x cancels out, that's all just equal to 1. And if I have that, then I can take the 4/7, bring it to the outside of the limit sign. Now what do I have? I have sine 4x, and I've got a 4x on the bottom. These are all being multiplied, so I can just kind of move them around. The 4x can go there. I've got a 7x on top. I've got a sine 7x for the bottom. And then I have a 1 over cosine 4x. So now, this because of the rule becomes 1. This because of the rule becomes 1. This, if you plug in 0 here, cosine of 0 is 1. You've got another 1, and your final answer is 4 over 7. So you have to manipulate, but it's okay. Just make sure that it's legal. This is equal to 1, and that wasn't a problem, but that gave us all the tops and the bottoms that we needed. I think that's our last question, and that should help you with those trig and the trig ones and the rules. That should work.